Hi everyone, I'm Anat, and I'll be talking today about the challenges of resolving prospects and customers' identities. Let me start with a story. Let's say that a few weeks ago, a colleague of mine at work told me about this really cool shop where I can buy rubber duckies online, and it's called rubberduckies.com. So I was browsing through that website and looked at my shop, and all of that was done on my work laptop. But then after a while, I got back to work. On my commute back home, I got back to that shop, this time on my mobile phone. I might even added one of those rubber duckies to the shopping cart, but then I got back home and forgot all about that. A week later, my best friend was having a birthday, and I recalled how much she loves rubber duckies. I was sure it was the perfect gift for her. Now, think of this story from the rubberduckies.com perspective. They would really like to sell me that rubber ducky. They have their marketing departments trying to convince me to complete that purchase. They want to know who I am so they can offer me the best rubber ducky for me. And yeah, well, in real life, this challenge is shared by many companies. Today, I would like to tell you what we did at Next Insurance to solve this challenge, so we can offer our prospects and customers the best insurance policies for them. And I would also like to tell you how we used graph databases as the base technology for our solution. But first, a few words about myself. I lead a team of data engineers at Next, and my team is in charge of all marketing-related data in our company. I love solving data-related challenges, and I've been doing it for quite some time. Next Insurance is an insurtech company which insures small businesses in the US. So marketing and data challenges, well, that's what we're going to talk about today. And what is that challenge? So as I mentioned in our rubber ducky story, we at Next face the same problem when we're trying to sell an insurance policy to our prospects. In a world where people are using multiple devices with multiple sessions, we get different cookies and tracking identifiers for our prospects. The even bigger challenge is that as an insurance company, we have two kinds of users. First, we sell our insurance products directly to the small businesses. So they come to our website and buy the insurance policies themselves. But we also let insurance agents to use our website, and they use it to quote multiple clients. So they do that very often with the same device and even the same session. Another challenge is that we insure businesses and not people. So we may get multiple contacts in a business, which eventually represent in our world the same customer. And then finally, for marketing purposes, we use prospects and not customers. And that is, we have very little information about these users. So how did we try to solve this challenge? First, we tried a default solution. We thought, that's easy. Let's just use a relational database. We're all data people, and that's the natural solution for us. We're very used to using those relational databases. So we thought that this database will hold all of our sessions and tracking data, and we will try to use it to identify who the prospects are. So we were using tables and joins to model our data. But that didn't work that well. We ended up with using super complex queries, and we were trying to identify who our prospects were using those queries. We were trying to figure out what their journeys at our website was, and maintaining this logic was a true nightmare. So every time there was a change in the product, it required major refactoring to support the business change. So then we started to think, what are relational databases actually good for? So relational databases are really good at searches. If I'm trying to get all the employees whose last name is Smith, for example, then I'm probably using the right tool for the job. Relational databases are also very good at aggregations. And if I'm trying to figure out what was the total sales amount for my orders, again, I'm probably using the right tool here. But these weren't the kind of challenges that we were facing. We were looking for the right tool for us. So we decided to look into graph database technology. And what is a graph database? A graph database is designed to treat relationships between data as equally important to the data itself. And if we have some terminology, in a graph database, data are stored as nodes and relations. So some relations have a preferred direction, but some are mutual. When querying a graph database, you can query for specific nodes or for specific relations. And one of the strongest features is that you can query nodes through their relations. And what are the graph databases good for? For starters, relations. If you're asking if Paul works with Anna, then this might be the right tool to consider. Another question that you might be asking is about pattern matching. And if you're asking if Jay Smith is actually the same person as Jenny S, then maybe yes and maybe no, but maybe using some other identifier that connects them, such as phone number, you would know the answer to this question. In that case, a graph database would be a very good tool for you. Graphs are also really good at answering centrality, clustering, and influence questions. So if you're wondering who's the right person to contact on LinkedIn regarding that job posting you were really interested in, then a graph database could be the right tool for you. So after we reviewed these scenarios, we definitely thought we had a case for using a graph database. And we thought it might be the right tool for identifying our customers. And we started by modeling the data. We had to think which nodes we should use and what relationships will connect those nodes. We defined our major data points, such as cookies and tracking sessions. We also used emails and other user identifiers whenever we had those available. Then we had to define the relationships between those nodes. So for example, the relationship between a tracking and a cookie was defined such that the tracking was using a specific cookie. And remember those agents that were purchasing on behalf of their clients? Well, we had some major data issues in those cases. An agent which was using the same device was very often causing data clustering, and that was unwanted in that case. So we wrote some heuristics to identify the data issues, and we ended up cleansing those. What we did is broke the cluster by deleting some of the unwanted relationships. As a note, we update the database continuously, but we identify the issues and run the cleansing jobs periodically. We ended up with a graph database, which represents our customers and our prospects' identities. This graph, it really revolutionized the way that we were able to identify related prospects and customers and businesses. It is now very easy to maintain, so it grows and easily adapts with our product changes. And this graph revolutionized how we can identify our prospects, and it supports the marketing business case in multiple ways. Let's see some examples. So attribution models. In marketing, we very often use attribution models to optimize marketing campaigns. Simplistically saying, let's say that you have a user that saw an ad on YouTube and then they clicked it. Then they saw another ad on Facebook and they browsed your website for a while. And maybe a few days later, they searched for you on Google. And then they ended up purchasing that insurance policy. So how do you know which ad was the most influential in their purchasing decision? Or in other words, how do you optimize your marketing budgets so that the best ads are served to the right customers? At Next, we now use a graph database to connect all those customers' touch points. And those are used for marketing campaigns optimizations. Another example is marketing audiences. Now that you have your prospects or customers properly identified, you can use that information to create marketing audiences. You can use the most impactful ad to the right prospect and send them the message so they will consider buying that insurance policy. The possibilities for using a graph database for user identities are actually endless. One other example is for identifying frauds in claims. You can identify fraudulent behavior by linking to customers that are filing an insurance claim. Similar claim patterns may lead to fraud investigations. Think, for example, of a case where a person was filing a claim and then they would open a new business and file a new claim with a new identity. You might end up identifying that they were the same business by looking deeper into those claims. So you might look at the address, phone, the business type. You would decide they were the same person, and you might look into a fraud investigation there. So to summarize, whenever you're facing a challenge, start with understanding your challenge. Start with properly identifying what it is and make sure you go over the possible solutions for it. Use the right tool for the job. Select the technology you want to solve the challenge that you're facing. As we saw here, relational databases are limited and weren't the right tool for our challenge. There are other databases out there, such as a graph database. The graph databases can solve a variety of problems such as relations, pattern matching, and clustering. And of course, a graph database can very easily revolutionize marketing optimizations and much more. Oh, and that rubber ducky? Well, my best friend absolutely loved it. Thank you.